get the following equation, that is tension BD vector divided by 3.3, the whole thing multiplied by the first component I vector. The cofactor is nothing but cross multiplication of 1.8 with 0 minus 2.1 with 0. So therefore both the terms are 0. We simply write it as 0 I vector minus, because the second term is minus. Here we find the cofactor for this j component. So the corresponding column has to be cancelled and the row also has to be cancelled. The cofactor here is 1.8 multiplied by 1.8, that is nothing but 1.8 square minus 1.8 multiplied by 0. So that is again 0. 1.8 the whole square. The simple idea is that we can just take these values and write it separately, so that it will be very easy for us to calculate the values. Say for example, we start with j term, that is 0, 2.1, then 0, 1.8, then 1.8 minus 1.8. Once again we write the j term 0, 2.1. Say for the first term 0i, we found out using this cross multiplying 1.8 with 0 and subtracting it with 2.1. For the second term we found out cross multiplying this term, then subtracting it this with. So like this we can find out all the other terms also. So here is j minus, so this component is column vector, this component is row vector. The cofactor is 1.8 multiplied by 1.8 is 1.8 square minus this 0 into 1.8. So this can be 1.8 square j. Similarly we can find out this value for k. So we strike this column and this row. We take this cofactor, it is nothing but 2.1 multiplied by 1.8, 2.1 multiplied by 1.8, 2.1 multiplied by 1.8 minus this value. So 2.1 multiplied by 1.8, 2.1 multiplied by 1.8 is there, minus 0. So therefore we get 2.8 multiplied by 1.8. Say this k term, we just remove this row and the corresponding column. We find this cofactor 1.80 minus 1.8, 2.1. We take this value 2.1 multiplied with 1.8, then minus this term we have to add. So here 0 is there, so this term get cancelled. So therefore the result is 1.8 multiplied by 2.1. So we go to the second term. That is tension BE multiplied by 3.3. We can do the same procedure here also. So first term is I, row cancelled, and the corresponding column also cancelled. We take the cofactor, that is minus 1.8 multiplied by 0 minus 2.1 multiplied by 0. So both the term 0, therefore we are getting 0i, then minus. So when we come to the second term, we remove this column and this row, we are getting minus 1.8 multiplied by 1.8 minus this term is 0, because here you have 0 value. So it is nothing but 1 minus 1.8 the whole square. Okay, so therefore this minus and minus becomes plus later on. So we can put this j value. Then we find the k vector. Here is k column and we remove this row. So the cofactor again here available here is 2.1 multiplied by 1.8 minus of 1.8 multiplied by 0. So you get only 2.1 multiplied by 1.8, which is k. So this is the expansion for tension B box product. Then the last box product gives you the value of first I component. The similar procedure is followed here also. You take this row and this column, you remove this. The cofactor is this, So therefore 0 multiplied by 0 is 0. Once again you have 0 term. So therefore naturally you have 0i. Then the second term j is minus. Here is one column, so you remove this column and the corresponding row can be removed. So here again you have 0 multiplied by 3 and 0 multiplied by 0. It gives you 0 value only. Then you have the k term. For k term, this row has to be, column has to be removed and the top row has to be removed. The cofactor here seems to be 4 multiplied by 3, but there is a minus sign. So therefore 12. Once again minus 0 gives you 0 only. So plus of minus 12 k vector, whole thing is equated to 0. So you are getting a lengthy equation with I, j, k terms. So adding all the items, adding all the I terms and equating to 0, we get one equation. Similarly, when we add all the I, j and k terms, we get 3 equations. This implies the first equation is we take the I value, all the 3 I terms are 0, so therefore the I term is neglected. There is no equation for that. There is no meaningful equation for that. We start with the j. So for j, we have TBD by 3.3 multiplied by minus 1.8 square. So this is the value that we get, minus 1.8 the whole square. So 1.8 with the minus term. Then here is our j term, that is nothing but plus TBE divided by 3.3 multiplied by this minus and minus becomes plus, so we get 1.8 the whole square plus. Here again it is 0, so this can be equated to 0. You can quickly realize that this minus and this plus, this 3.3, they can be cancelled and they leave away with a simple equation, tension BD minus tension BE equal to 0. This implies tension BD is equal to tension BE. So we are getting a simplified equation wherein both the tension values are same. Now we move on to the k term, that is TBD divided by 3.3 multiplied by 2.1 multiplied by 1.8. This is the first term. Then the second term is again TBE divided by 3.3 multiplied by 2.1 multiplied by 1.8, 2.1 multiplied by 1.8. Okay, this is the second term. Then here is the third term for k, that is nothing but minus 12. So when we equate it to 0, once again we know TBD and TBE are equal. So we can take any one of the value. We can put TBD equal to TBE. So we can simply take TBD out and we can multiply this by 2, twice 2.1 multiplied by 1.8 is equal to 12. So from this we can straight away find the value of TBD. So this can be possible only when TBD is equal to TBE. Here I am substituting TBE as TBD because I am getting TBD as TBE. So this can be straight away found out as 12 multiplied by 3.3 because the denominator goes to the other side and becomes numerator. All these numerator values, when it goes to the other side, they become denominator. So it is 2.1 multiplied by 1.8. So we can get this value as TBD. Now let's see, the first term is 12 multiplied by 3.3 divided by 2 divided by 2.1 divided by 1.8. So the answer is 5.238. The answer TBD, we are getting 5.238. Since the TBD and TBE are same, both the tension values are 5.238. So it's a very important answer, step answer. We can write it as TBD is equal to TBE, which is nothing but 5.238 kilonewton. 5.238 kilonewton positive